Hey guys, we got chapter 15, problem 1. All right, so for each pair of substances listed here, choose the one that has the larger standard entropy value at 25 degrees Celsius. So we got the same amount, right? Same number of moles, same number of particles of each. Then explain. So for A, we have a solid and we have a liquid. Well, we know liquids, right? Liquids, right, have greater entropy than solids. Right, liquids are free to move relative to one another, where solids are locked in position. So if we're free to move, we can have more randomness. All right, next one. And I had a typo here. I had a typo right here. All right, so for ethanol, it's C2H5OH. I don't know if I might have fixed it for you guys. I might not have. If it says C2H4, I apologize. So you got liquid ethanol and liquid dimethyl ether. So hint, which molecule can hydrogen bond? All right, because if you look, there's 6 hydrogens, 2 carbons, and an oxygen in each. So they have the same molar mass. All right, so, right? But if you look, this is different than this, right? This is an ether, and it's symmetrical. Ethanol is asymmetrical in hydrogen bonds. Okay, and so because, I want this. So ethanol is asymmetrical and hydrogen bonds, right? Which makes it more complex. All right, and so ethanol or diethyl ether will be smaller. Next one, C, argon and xenon. Well, just an atom. Xenon is larger molar mass, and that's more entropy. CO or CO2. All right, well, CO2 would have, it's larger, right? So if we're larger, that means we have, plus we have an extra bond, right? CO has 1 bond, CO2 has 2 bonds, so that means there can be more bond vibrations and rotations and whatnot, and there's more mass, so that's all more entropy. O2 and O3, same reason. All right, it's also larger, more bonds, more vibrations, rotations, right? NO2 or N2O4. Well, N2O4 is larger, right? And so that is, right, because N2O4 is has more bonds, so that's more molecular complexity, more mass, more electrons, more protons and neutrons, right? The 1 mole of dinitrogen tetroxide has a larger standard entropy than 1 mole of nitrogen dioxide. All right, and you can look at the appendix of your textbook and compare the actual values, but that's how we would quickly look at this. All right, so that is problem 1. I'll see you next one.